In this video, we're going to use the determinant to solve for the specified variable. We'll begin by using the definition of the 3 by 3 determinant to rewrite the left side of our equation in terms of x. Then we'll solve the equation. To find the value of 3 by 3 determinant, we need to multiply each element in any row or column by its cofactor and then add the results together. The cofactor, a sub ij, is equal to -1 raised to the power of I plus j, which represent our row and column positions respectively, times the minor of ij, which represents the minor of element a I sub j. We call this process expanding across a row or down a column. Here, since we wish to solve for x, we'll expand across row 1. So we'll take -1 raised to the power of 1 plus 1, which is the position of x in our matrix, times x, times the minor, which we find by taking an imaginary line to block out row 1 and column 1, and write the remaining values as a 2 by 2 determinant, plus -1 raised to the power of 1 plus 2 times 1, and here, blocking out row 1 and column 2, we'll take the determinant of -6, 3, -1, and 3. -6, 3, -1, and 3. Continuing our expansion, we'll see if we can fit this last piece along the bottom here. Plus -1 raised to the power of 1 for row 1 plus 3 for column 3 times 1 times the minor of row 1 column 3 which is -6, 4, -1, 3. Let's start a new screen so we can simplify this expression. Simplifying this expression, we get -1 raised to the power of 2, which is +1, times x, times the determinant of this 2 by 2 matrix, which is 4 times 3, which gives us 12, minus 3 times 3, which gives us 9, plus -1 raised to the 3rd power, which is -1, times 1, times -6 times 3, which is -18, minus -3, plus -1 to the 1 plus 3, which is -1 to the 4th power, which gives us +1, times 1, times the determinant negative 6 times 3, which is negative 18, minus negative 4. One times x is x, times 3, which gives us 3x, since 12 minus 9 equals 3. Negative 1 times 1 is negative 1. And here we have negative 18 plus 3. So this gives us negative 1 times negative 15, which is positive 15. And then we have plus 1 times 1, which is negative 1, times negative 18 minus negative 4, which is negative 18 plus 4. So here we have negative 1 times negative 14. Oops, I apologize. This is actually a positive 1, because 1 plus 3 is 4. 1 to the 4th power is 1. So let's revisit that. 1 times negative 14 gives us negative 14, and we set this all equal to negative 2, which is what our equation was set equal to at the beginning. Combining like terms, 15 minus 14 equals 1. 3x plus 1 equals negative 2. Subtracting negative 1 on both sides. 3x equals negative 3. Dividing both sides by 3 gives us x equals negative 1. Therefore, the value of x in this equation is equal to negative 1. That concludes our example. I hope you found it helpful, and we'll see you next time.